Welcome to the Deep Blue on My Doorstep podcast. I'm Tracy Ainsworth from the University of New South Wales. In this podcast series, we will talk to marine experts about the marine environments that we have right on our doorsteps and what we can do to help conserve and protect these blue spaces. Dr. Laura Parker, a very big welcome to the Deep Blue on My Doorstep podcast. Laura, you're a Scientia Fellow and Australian Research Council Fellow at University of New South Wales, Sydney. You work with Department of Planning, Industry and Environment at Port Stephens. For many listeners, impacts of changing marine spaces for things like corals and kelps, something they're used to hearing about, but particularly for people in New South Wales and waterways and estuaries around New South Wales, these are also changing marine spaces, and those changes are felt by shells, oysters and mollusks, and this is what you've fallen in love with and where your work is focused. Thank you so much for joining us today to talk about your research. For the past several decades and coming into the decades ahead, this is really an era of rapid change. We talk a lot about what's going wrong with the marine environment and the challenges that are to come. But the impacts for mollusks are very real, and they're happening right now, right? And that's what your research is looking at.
Yeah, that's true. And firstly, thanks for having me, Tracy. It's such a pleasure to be here. So the impacts for mollusks and things such as oysters are very real. Oysters in particular have been on the decline for many years now due to things such as overharvesting, habitat modification, pollution, disease. But now they face what I feel is an even greater threat, and that's the threat of climate change. So as I guess many people have heard from the media, over the last 200 years, there's been a huge amount of carbon dioxide that's released into our atmosphere. And this carbon dioxide has caused a lot of changes in the ocean and is causing a lot of changes. So the ones that I work on are predominantly the warming of the ocean as well as ocean acidification. So our atmosphere is warming, and this is causing a change in the temperature of the ocean. But at the same time, our oceans are absorbing carbon dioxide. And once absorbed, the carbon dioxide reacts with seawater, and it's causing the pH of the ocean to drop. So my research is really focused around looking at how that change in temperature and pH of the ocean impacts oysters and other mollusk species.
So marine invertebrates and oysters, mollusks, they're in that intertidal zone, right? So right in the shallowest parts of the ocean and the parts that can get really, really hot. So they're really susceptible to unusually hot conditions and things like heat waves. They can't just up and move to a cooler spot like other things can. For the ocean, this is the hottest place to be, and we've got a changing climate, as you've been talking about. Just how difficult a place to live is that intertidal zone as climate change happens?
Yeah, well, that's right, Tracy. So a lot of mollusk species are sessile organisms, so they will spend the first part of their life cycle in the water column where they're swimming around for a short period of time, and then they will settle out of the water column and cement themselves in a spot where they are stuck for the rest of their life, and they can't move away from bad conditions that are occurring. So in that zone, they already face a number of stresses such as fluctuating salinities, periods of time where they're out of the water, so they experience hotter temperatures, periods of time where they can't feed, they've got low oxygen. And on top of this, they're also now going to be experiencing marine heat waves, a much higher frequency and severity of those heat waves, and also ocean acidification whilst they're in the water. So it really is going to be a much harder place for them to live.
And your research is about future-proofing. So you're looking into the future and looking at how can these wild systems and these wild places, organisms, be helped to get through what's coming into the future. How exactly do we future-proof a wild population of oysters?
Yeah, so our research is focused around using selective breeding programs to specifically breed oysters that can overcome the impacts of climate change. So we do things such as expose adult oysters to climate change stresses while they're producing their offspring, so their eggs and sperm, and then we look at how that impacts or improves their offspring. We also do things such as pair-mated breedings, where we will breed one male and one female together to make what's called a family line. And we do that a number of times, and we assess how each of these family lines responds to climate change. And we then take the ones that are doing better and we breed them on.
So, Laura, what kind of scale of facility do you need to do this kind of research?
You need a really big facility, actually, and I'm very fortunate to have access to hatcheries at the Port Stephens Fisheries Institute. So at the Port Stephens Fisheries Institute, the things there are specially designed to breed mollusks and oysters specifically. So we have access to our own oyster hatchery, where we set up big 750-litre tanks in the hatchery. Each tank has hundreds of oysters in them. We then change the temperature and the pH conditions in those tanks, and we look at how the oysters respond and also their offspring.
You mentioned family lines before, that you track family lines or family groups in these studies. How many generations do you follow that through?
Well, I'm very fortunate in my research to be working with the New South Wales DPI, because they have access to a Sydney rock oyster selective breeding program. So this program's been going for many years to breed oysters which have resilience to things such as disease and grow faster. So these are traits that are important for the oyster industry in New South Wales. So I've been really fortunate to be able to test each generation that they do of this selective breeding program over a number of years now. So I think at the moment we're going on to our third year of selection and of testing of these family lines. So we're really fortunate to have access to that program.
So for 3 years, is that 3 generations, or is that how it works?
Yeah, so in this particular breeding program, in this particular project, we have, since 2017, we've assessed the family lines that have come through. So we take a subset of the family lines that are produced, and we expose them to the climate change stresses and identify which ones were the best, which ones were also the worst, because it's also important to know the reasons why some are good and some are bad. And then the following year, we look at their offspring and the new pair matings, and we see what happens with those.
So what kind of things are you looking for that don't work?
One of the important things that we look at in adults is the chemistry of their blood. So a really important indicator of whether they're very stressed by the conditions, especially ocean acidification, or whether they're more resilient is the pH of their blood. So we look at how much the pH is dropped from their normal value, and the ones that are able to maintain that pH value closer to the normal value are the ones that are more resilient. We also look at things such as their shell length, because the growth of the shell is something that's really impacted by these ocean changing conditions. So oysters that are able to grow better in these conditions are ones that we also term to be more resilient.
You mentioned some of these populations you already know are resistant to things like disease. Does that give them an advantage or a disadvantage under these scenarios, or does it depend on the family line? Is there any benefit that comes from other forms of resilience?
At the moment, in terms of climate change resilience, we haven't found any difference between the way a disease-resistant line or not resistant line responds. We do know that when we're breeding for resilience, you often get what's known as trade-offs. So you might have an improvement in one trait, such as disease resistance, but then you'll see a decrease in another trait. So a lot of the disease-resistant oysters maybe don't grow as well as oysters that have less resistance. So we haven't found that in terms of disease-resistant lines yet, but we have found it in terms of their tolerance to other stresses in the environment. So at the moment, oysters that are tolerant, say, to ocean acidification, they have less survival if they're exposed to other normal stresses in the environment, such as a change in salinity or when food concentration isn't high.
That's really interesting. Does it make it difficult then for selecting how to go forward, balancing out that resistance to climate and then just the other changes that they're having in the environment? Do you have a way that you try to balance that to make a selection for which group might be the ones to focus on?
Yeah, that's a really good question, and that's exactly where our research is focused at the moment. So we were working at much more of a smaller scale before in terms of breeding resilience and looking for resilience. So when we found families that were resilient, we thought, great, we've got what we need. But the further tests did indicate, like I was mentioning before, that was taking away and leading to trade-offs. So what we've done now is we're looking at a much bigger scale in our experiments, looking at a huge number of families, and we're focusing on their physiology a lot more, looking at all different aspects of their physiology to try and find out just how far we can push them in their resilience for climate change without taking away from these other important traits that they need, like resistance to the other stresses.
Yeah. So you talked about disease and a lot of these oyster populations having already been impacted and constrained by changes in the environment. Have we lost some species of oysters along the coastline already?
Yeah, in certain areas we have. So disease is a really big problem for oysters in New South Wales and other parts of the coast. So we've seen populations, all but decimated in some regions. So the use of these selective breeding programs have been really important in places around Sydney. Also with other species such as the Pacific oyster, we're now seeing the real importance of these selective breeding programs for places such as Tasmania, where these diseases have come through and all but wiped out the natural population. So in these areas, really, to have sustainable populations, you're needing these disease-resistant oysters that can survive an outbreak.
So you need disease-resistant oysters to come back into these populations, and then also future-proofed populations as well. Are there other factors that you need to consider looking forward for what's best to prepare these oyster families for?
Well, I think some of the stresses that I touched on before, these oysters are going into an intertidal environment where just naturally they're exposed to fluctuating conditions with salinity. Food concentration is not always at its highest. They are exposed to things more and more like depleted oxygen levels due to runoff from fertilizers and things like that. And these organisms, they need to be able to tolerate that wide range of conditions that occur in the intertidal zone.
That's really interesting, particularly with your research that looks at traits being passed across generations. That some of your research looks at how you can influence what the adult experiences and then how the next generation responds. Which is a really interesting insight into, cross-generational change. Can you explain how you track those responses across generations?
Yeah, so this is really work that I'm very interested in. So we look at these intergenerational or transgenerational impacts by exposing the parent, and then we look at how their offspring responds due to that parental exposure. So we focus mainly on assessing the offspring during their early life history stages, because this is the time which oysters and other marine organisms have been found to be very vulnerable to climate change stress. So there's a period for oysters around 3 to 4 weeks where they're swimming around in the water column and they're developing through a series of larval stages. And it's at this time that the oysters will develop their shell. So it's a really vulnerable time for them. So what we do is we expose the parents and collect their offspring, and then we see how those offspring respond to climate change. So what we found now is that during those early life history stages, the offspring are much more resilient. And then once they settle out of the water column, We then remove them out of the hatchery so they're no longer exposed to any climate change stresses. We put them out on the oyster lease here in Port Stephens. And then after a year of being out there, so once they've reached reproductive maturity, we bring those oysters back in and then we expose them again. So they're now adults that are able to reproduce themselves. And what we found is that in those adults, despite spending all that time out in the estuary where they're away from the CO2 and temperature treatments, once they come back in, they've still got that resistance that they had when they were early offspring. And what we also found interesting is that once we collected and exposed their offspring, they still had the resilience as well. So these transgenerational effects are able to persist quite a long time and across different generations.
That's really interesting. Does returning them to the natural environment, does that help you look at how well they survive under normal fluctuating conditions? Or do you just put them out and see what happens?
Originally, we put them out there because it's really impractical to be able to keep oysters in the hatchery for their entire lifetime. Yeah. Each adult oyster requires 1 litre of algae per day to survive. So if we're talking about 1,000 oysters that we're keeping in there, it's a lot of upkeep of the oysters, over a year-long period. So our original reason for putting them out there was just put them out there, and we wanted to do a multi-generational study and bring them back in. Yeah. But yes, we did just by chance find it very interesting that they were able to maintain the resilience when they weren't even under the pressure anymore. For us, however, the question would be, can they maintain that resilience? Are they still able to survive when they're under both the pressure of that natural environment and climate change? And I think that's going to be the question moving forward, since all of our research has been done under ideal conditions in the laboratory. Yeah. What happens when they're under both of those conditions, the natural field conditions and also climate change? And I think that is going to be the very big question moving forward.
Yeah, definitely. That's a really interesting fact about how much they eat in a day. And it really kind of paints a picture for how important they are out in the wild and how important oysters are along the shorelines. I mean, that's a lot of food that they're taking out of the water to grow that much.
Yeah, definitely. Each adult oyster out in the estuary can filter up to 200 litres of water each day. So when you start thinking of it that way, if you're thinking about oysters disappearing from an area, you can really start to think about what that means for the region in terms of water quality. We do experiments and just little trials to show children in daycares and schools about their filtering capacity, where we'll put 10 oysters in just a little aquarium and fill the aquarium with algae so that you can't actually see the oysters anymore. And within 20 minutes, the water is clear.
Wow.
So, yeah,
that's
really
awesome.
gives you an idea of the benefit that they have for the environment.
Yeah, absolutely. You grew up in Western Sydney, not really in the coast. What started your work in this area?
Yes, I did. I was about an hour away from the nearest beach, so it wasn't a place that I went to often. I've always loved the ocean, but that definitely wasn't what I set out to do when I went to uni. I did a Bachelor of Biological Sciences, but I wanted to be a forensic scientist at the time.
Wow.
Yeah, so much different to where I've ended up. It wasn't until third year that I started doing a lot more environmental science courses, and one particular course was aquatic ecology. And I just fell in love with it. I had a fantastic teacher. We did field trips where we went out to the mangroves, and we went out to rocky shores, and we sampled what organisms were there, what their abundance was, their distribution. And, I remember the first field trip was to a mangrove where we were walking through with mud, up to our knees. And something about it I just fell in love with. And, it's really interesting to me to know that everything in the marine ecosystem has a reason for being there. It's not just coincidence that it's there. They all interact with one another. And yeah, it just instantly was something that I had to jump ship and work towards after that.
Nice. That's fantastic. That forensic science mindset, though, I mean, that must give you an interesting way of looking at some of these problems around climate change, impacts in marine ecosystems, and working out what the problem is and what are the culprits, I guess. Do you think that's given you a different way to look at these systems?
Yeah, I hadn't actually thought about it that way before, but I think that's probably right. I do like to think through these things and the reasons why they're happening and what we can do about them. It's really something that I find interesting, and solving that puzzle is something that's very enjoyable to me.
Nice. Following on from that, is there a marine space that now continues to influence you and your research that's become really important to you, spending your life improving the lives of oysters?
Yeah, I think it's where I live now at Port Stephens. It's a beautiful spot here. We're surrounded by seawater. Pretty much anywhere you go, there's seawater, and there's so many different marine habitats you can go. You can go to an ocean beach, you can go to a bay, to the estuary. Oysters are a very big part of this area. It's where a lot of oyster farming occurs. And it's the place that I raise my children, and I just, everywhere around here inspires me, and continues to make me want to do what I do now.
Your research also crosses generations for oysters and shells. What about people? What does the future hold, and what can people do to help improve these marine spaces and estuaries?
Yeah, look, I think it's very important that we do something now, that people start to realise that what they love about marine spaces, what we get from marine spaces, their importance, is all going to disappear unless we start making a change now. And we start embedding the importance of that in the next generation as well. Obviously, from my point of view, I think it's so important that we start to look at our carbon emissions and ways in which we can try and reduce those, but also ways in which we can reduce other stresses on the marine environment. Things such as, we hear a lot about plastic waste at the moment, making sure when you go to the beach you take your waste with you, making sure when you're fishing you take your hooks and your line. Don't be tipping things like paint and oil down the sink, because they're going to end up in the ocean. Just little things like that we can do to try and minimise impacts on the ocean, I think, are going to be important. In terms of oyster restoration, there are programs going on in New South Wales at the moment that are specifically dedicated to start to restore natural oyster reefs along the coast of New South Wales. And I think these are great initiatives for volunteers to get involved in and help out in these programs.
So can people look these programs up on the internet and find what's around locally for them that they can get involved in?
Yeah, I know there's programs that are starting up here in Port Stephens. At the moment, they're not looking for volunteers, but I think that will start in the near future. So just keep an eye out, look it up. There will be opportunities very soon to start getting involved in these important projects.
Nice. Do you see a lot of plastic pollution in around the oyster beds and oyster leases?
Yeah, I do. We often go walking, as a family around the rocky shore and around where oysters are. And yeah, unfortunately, there is a lot of plastic pollution. Here, it's not as bad. Up at Port Stephens, it's quite a pristine location. Our population is not as large in and around the waterways as it is maybe in some of the more populated areas, but it definitely is a problem.
So, Laura, a lot of your research is looking into the future for what's coming for oysters and how to prepare. But history and ecological history of our blue spaces is also really important to know what was there and what these systems were like before we started to change them. one way that people are embracing that is through learning more about the Indigenous history of Australia and Indigenous knowledge, because people have been living with these organisms and these places for many, many generations. And there's a huge breadth of knowledge there that can tell us about these places. How important is it that we learn the ecological history for these kinds of environments?
I think that's a really important question, Tracy. As an Indigenous Australian myself, I think it's very important. Indigenous people have had a rich history of interactions and unbroken custodianship with sea country for thousands of years now. So I think it makes sense that we start to incorporate some of this traditional knowledge into what we're doing now, to find out things such as, what was there before? When did it change? Why? Was there anything that happened at that time? And equally important, I think, is that we start to incorporate the aspirations of Indigenous Australians into our research. So, engaging with Indigenous Australians from the beginning of our research to find out how we can move forward in mutually beneficial partnerships and research programs.
That's fantastic. Is your work starting to do this at Port Stephens?
Yes, so our research, we're actually working with the traditional owners of the Palmerstone Passage region in Moreton Bay. So they're having a lot of issues with a decline in the oyster populations due to environmental factors in the area. So one main issue they're having there is things such as sedimentation, as well as salinity problems and disease problems for oysters. So one of the big aspirations of the Indigenous community there is to try and restore these oyster reefs in the region that are very culturally important to them. So we're using some of our selective breeding techniques to try and help in that region and restore oysters.
That's fantastic. And that's Moreton Bay up at Brisbane in the mouth of the river.
That's right.
Yep. Nice. That's a fantastic place to go and work.
Yeah, I visited last year for the first time. It was really beautiful.
Nice. Fantastic. Thank you so much, Laura. That's an incredible perspective that you have on our coastlines and the future and also the past. So thank you so much for joining us on the podcast today.
Thank you so much for having me, Tracy. It's been a pleasure.
Thank you for listening to the Deep Blue On My Doorstep podcast. Don't forget to check out our website at events.unsw.edu.au, where you'll find all the photographs from this podcast series featuring the beautiful places that we've been discussing and the organisms found in these blue spaces.